Good morning, fourth grade. So we're going to go ahead and get started. I think I'm slowly but surely getting better at this. Today is Wednesday, April 1st, 2020. Joke of the day. What is a leprechaun's favorite cereal? It is Lucky Charms, which, actually, fun fact, it was my favorite cereal when I was younger. I mean, I still love it. I just haven't had it in a long time. And then when I went grocery shopping the other day, I saw them and it reminded me of this joke that I always tell. And so I am acting like a child again and eating Lucky Charms. So I had it for breakfast. Okay, so we are on week 2, day 3 in your packet. I noticed this morning when I was looking over the work, the learning target for today doesn't actually match what we're doing. So they must have just made an error there. So we're actually going to forget about that learning target because we are not going to be rounding today. Today we are going to be solving word problems similar to what we did yesterday that include that comparison. So when it says however many times as much. All right, and we're going to be using those tape diagrams and the RDW strategy again today. Okay, so if you're looking at your daily fluency, it says, are the following statements always true, sometimes true, or never true? How do you know? Also, my cat's just going to keep making little appearances back there because it makes her happy and keeps her from jumping on the table as much. So let's look at the first one, and we're going to decide if these are always true, sometimes true, or never true. Okay, so the first one says, the sum of 3 numbers is odd. Okay, so I want you to think about that. The sum of 3 numbers is odd. So let's think about 3 numbers that we could add together because I know that sum means to add. And let's see if we get an answer that is an odd number. Okay, so I'm just going to start with some random numbers. Okay, so I'm going to say, let's try 4 plus 3 plus 1. All right, well, 4 plus 3 is 7, and 7 plus 1 is 8. So this gives me, right here, 8. So is 8 an odd number? No, it's even, right? Okay, so it didn't work that time. Let's try some other numbers to see if it's possible to get an answer that's odd. Okay, so let's try 2 plus 4 plus 1, okay? 2 plus 4 is 6, and then 6 plus 1 is 7. And I know that 7 is an odd number, so I would say that this statement is sometimes true, okay? Because I know that it can't always be true because we just said that we could get an even number like 8. I know that it can't be never true because we got a number as we got an odd number as our answer when we did this and got 7. So if the sum of 3 numbers is odd, I'm going to say that that one is sometimes true. All right, that one is sometimes true. Okay, so moving on to number 2, multiples of 5 end with 5. So I want you to take a second and think about what a multiple is, okay? We've talked a lot about factors and multiples this year, so remember that when we are talking about multiples, that is all of the numbers that you say when you're skip counting by that number. So if it's asking, do multiples of 5 end with 5? We're going to, let's start skip counting by 5, right? So the multiples of 5 are 5, 10, 15, 20, 25, 30, and so on, okay? We can keep going forever. So now let's look at these numbers, and multiples of 5 end with 5, okay? Well, let's look at our options first. Always true. This definitely isn't always true because I see that 10 is a multiple of 5 and it doesn't end with a 5. 20 is a multiple of 5 and it doesn't end with a 5, right? We have sometimes true, which is correct, right? So here's where it ends in 5 in these numbers. So it is sometimes true or never true. Well, it definitely can't be never true because we listed our multiples of 5, or some of them, and we can see that some numbers do actually end with 5. Okay, so we're also going to go with the sometimes true here. Okay. So, looking down to number 3, if you add 1 to an odd number, you'll get an even number. Okay, so let's start with an odd number. You can think of any odd number here. Again, I'm just giving you one example. There are multiple examples for these problems. All right, so I'm going to start with the odd number 9. Okay, if I add 1 to 9, I get 10. Is 10 an even number? Yes. All right, let's try another one. We'll use the odd number 13. And if I add 1, I'm going to get 14. Is 14 an even number? Yes. All right, let's try one more just to see. If I take 97 and I add 1, I get 98. Is 98 an even number? Yes. So I would say that this statement is always true. If you add 1 to an odd number, you'll get an even number. Always true. Okay? Moving on to number 4. If you add a multiple of 10 to a multiple of 5, the answer is a multiple of 5. All right? That's a lot. So let's remember. A multiple of 10. So a multiple of 10 means we're just going to skip count by 10, right? So 10, 20, 30, 40, 50, and so on. Okay? Now, let's skip count by 5. So let's do some multiples of 5s. 5, 10, 15, 20, 25, 30. All right? And those are just some of them, right? There are lots of options here. Okay? Now, let's try taking a multiple of 10 and a multiple of 5 and see if that answer is a multiple of 5. All right? So I'm just going to say, let's take 20 and let's add it to 5. Okay? When I do that, I get 25. Now, is 25 a multiple of 5? Well, yeah, I can see it right there. Remember, multiples of 5 always end in 5 or 0. Okay? Let's try another one just to be sure. Let's take, this time I want to take 40, and I'm going to add 20. And when I do that, I get 60. Is 60 a multiple of 5? Yeah, if I keep skip counting by 5s, 30, 35, 40, 45, 50, 55, 60. Eventually I'm going to get to 60, right? So I'm going to say that this, number 4, is always true, okay? Always true. When you add a multiple of 10 to a multiple of 5, the answer is going to give you a multiple of 5, right? And then number 5, if you add 2 to an even number, you'll get an odd number, all right? So again, let's think of those even and odd numbers. All right, I'm going to start with, I'll start with 16, okay? Let's add 2. If I add 16 plus 2, I'm going to get 18, okay? Is 18 an odd number? No, so that didn't work. All right, let's try another one. Let's try 32 plus 2. When I add 32 plus 2, I'm going to get 34. Is 34 an odd number? Nope, it's even. All right, so I'm going to say that this one is never true. Number 5 is never true. When I add 2 to an even number, I'm always going to get an even number, right? Because we've kind of skipped over that odd number. So 42, 43, 44. Okay. 84, 85, 86, right? I'm always getting back to that even number. Okay, so today's fluency was really just kind of a brain teaser, what I would call a brain teaser anyway, that really gets you thinking about properties of numbers and, you know, the rules and all of those things that we've covered in school this year. Okay, so let's go down to task A. I'm also going to be posting the Fluency as your problem of the day every day because they are pretty quick and easy and something that you can do even if, you know, something happened today and you don't get to do your daily task. If you're following me on my teacher Instagram, then I'm going to start posting those as our problem of the day. If you want extra work, you want extra problems, and you're just that go-getter, let me know and I will send you other problems. But I'm trying not to overwhelm you guys too much with, the problems to complete. Okay, so task A, it says, read each task carefully and follow the directions. Make sure you write an explanation and show your work. So at a neighborhood park, and remember, as I'm reading this, I want you to be doing that first step, the R, where you are reading with me and you are underlining important information, okay? So what you know, and then squiggling the questions that you're trying to answer. At a neighborhood park, there are 11 spaces for bicycles on a rack by the basketball court. The bicycle rack by the playground has 3 times as many spaces for bicycles as the one by the basketball court. Write an equation and create a drawing that could be used to find the total number of bicycle spaces on the rack by the playground. Okay, so let's go through that again. And as we read this time, I'm going to start drawing a model. Okay, I'm going to be thinking about what I can draw to represent this word problem. So at a neighborhood park, there are 11 spaces for bicycles on a rack by the basketball court. So I'm going to put B for basketball court. Okay, and I'm going to draw one unit and label it 11. Okay, that represents that there are 11 spaces for bicycles on the rack by the basketball court. All right, now the bicycle rack by the playground has 3 times as many spaces for bicycles as the one by the basketball court. Now I see those important words, times as many. Okay, how many times as many? The playground has 3 times as many spaces. So I'm going to write P for playground. And then I'm going to show that the rack by the playground has this amount, but then it also has this amount 3 times, right? Because it has 3 times as many spaces. So I'm going to draw 2 more units to show that it has 3 times as many spaces. And if you want, you can go ahead and each one input. Well, each one is definitely going to be worth 11 spaces, okay? Write an equation and create a drawing that could be used to find the total number of bicycle spaces on the rack by the playground, okay? So what is the total number of bicycle spaces? So you can mark this, I'm going to mark this with an S, whatever letter you use to label your unknown is totally fine. So now I'm going to write an equation, all right? So I'm going to go back to those words. I remember those important words, 3 times as many, all right? So I really want us to be thinking about multiplication when we solve this problem because of those words, 3 times as many. So we're going to start with this 11, okay? And I'm going to say, all right, I know that the bicycle rack by the basketball court had 11 spaces. And actually, I'm going to write that down here, sorry. And if the playground has 3 times as many spaces, I know that I'm going to multiply this 11 by 3. And I can see that over here where I drew my tape diagram, okay? And now I'm just going to solve using the standard algorithm. So 3 times 1 is 3. 3 times 1 is 3. So 11 times 3 is 33. All right, so let's go back. And I've noticed that in these problems lately, they haven't had actual questions. They're kind of framing their questions as a statement that's saying, write an equation to show this instead of asking you. So write an equation, create a drawing that can be used to find the total number of bicycle spaces on the rack by the playground. So you could write a statement like, there are 33 total spaces by, well, it's just alerting me that I have a meeting, by the playground. Okay? Make sure you have your statement because, again, it is a word problem. Right? There are 33 total spaces by the playground. Whatever way that you wrote your sentence is totally fine. If it doesn't match my statement, that's okay, as long as it's still answering that question. All right, so we have our model, we have our equation, and we have our statement, which means we are done with this first word problem. Okay, let's go ahead and move down to task B. All right, erase my board. So Ciara recycled 54 pounds of paper. Please make sure you're annotating your problem if you haven't already. She recycled 9 times as many pounds of paper as Monica. Write an equation and create a model that can be used to find M, the number of pounds of paper Monica recycled. Then solve the equation to find the number of pounds of paper Monica recycled. Okay, so I am noticing, based on what we did yesterday too, maybe you're thinking, so this is one of those problems where I still see times as many, but it's telling me that it already gave me how much Ciara recycled, and now it's telling me that that number is 9 times as many pounds of paper as Monica. But we don't know how many pounds of paper Monica recycled, all right? I also noticed that here they gave us a specific letter that they want us to use for that unknown, okay? So they want us to use the letter M to represent the unknown, which is the number of pounds of paper Monica recycled. Make sure that you're paying attention because sometimes they are going to ask you to use a specific letter, and you want to make sure that you use the letter that they asked for if they did say that. All right, so as we read again, I'm going to be drawing a model. You should be drawing with me, or you should be checking your work. All right, if you want to go ahead and pause me here so that you can draw the model first and then check, I really encourage that. So Ciara recycled 54 pounds of paper. All right. So everything that Ciara recycled, the total amount was 54 pounds, right? And it also tells me right away that this amount that she recycled is 9 times as many paper, as many pounds of paper as Monica. All right? So we don't know how much, I'm going to start with Monica actually. We don't know how much Monica recycled, right? Because it said, find M, the number of pounds of paper Monica recycled. All right? So I have Monica here, and I know that she did some amount, and I'm going to label it M just like it said. She recycled some amount of paper, and I'm going to label it M, okay? Now I know that Ciara recycled 9 times that amount, so let's see if I can show you. All right, so Ciara recycled this amount 9 times. Okay, so I'm going to draw 9 units to show that she recycled 9 times more. Sorry, guys, I can't do it like that. 9 times more than Monica. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now, I also know that the total amount that Ciara recycled is 54 pounds. So I know that all of this represents 54 pounds. All right. And the answer that I'm trying to find, my unknown, is how much Monica recycled. All right. So that's my M right there. That's what I'm trying to figure out. Okay. So remember, this is kind of like the reverse of what we just did. Right. We know the total that Ciara did, and we know that she recycled 9 times more than Monica, but we want to know how much 1 unit is worth. We know that 9 units is worth 54 pounds. We want to know how much is 1 unit worth. So instead of multiplication here, I'm going to be using the opposite, which is division, okay? So I'm going to say 54, and there are 2 ways, again, that you can think about this, kind of like we talked about yesterday. So you could say, okay, however much Monica, M, recycled, Ciara recycled 9 times as much, all right? So 9 times as much. And because she did 9 times as much, she recycled the 54 pounds, okay? So the M times the 9 gave us how much Ciara recycled, which was 54 pounds, all right? Now, you could either think, what times 9 gives me 54, okay? And we can also write this, using division, okay? So we have M times 9 equals 54. I can flip this and say, okay, well that means 54 divided by 9 is going to give me M, which is the amount of paper that Monica recycled, right? So 54 divided by 9, again, 9 times what gives me 54, that's going to be 6. M is going to be 6 pounds. All right. 6 pounds, because 54 divided by 9 gives me 6, and 6 times 9 gives me 54. All right, so you should also write your statement. I'm not going to write it this time, but I will say it for you. So if I was going to answer this question, I'm finding the number of pounds of paper Monica recycled. I would say Monica recycled 6 pounds of paper. Okay, there's that. All right, moving on to task C, which is our last problem. Okay, it says, let me erase my board. A store ordered small paper cups and larger paper cups to promote the grand opening. 12 times as many small paper cups were ordered than large paper cups. If there are 96 large paper cups that are ordered, how many small paper cups, they left a word out, how many more small paper cups were ordered than large? Okay, solve using a model and an equation. You have probably seen a problem just like this before. It was on one of our very first end of module assessments, I think. So again, we're just going to go through it again and draw a model and then write equations to solve. Now, let's do that first, then we'll talk about what I was going to say. All right, so a store ordered small paper cups and large paper cups. All right, so large paper cups, I'm going to say large and small. Okay, I know that much. 12 times as many small paper cups were ordered than large paper cups. Okay, so let's read that again. 12 times as many small paper cups were ordered than large paper cups. So I know that they ordered some large paper cups, all right? And then they ordered 12 times as much for the small paper cups. So again, kind of like my last problem, I'm going to draw 12 units to show that they ordered 12 times as much. So I'm going to do that real quick. You can do the same. 1, 2, 3, 6. Okay. All right, so, sorry guys, I'm struggling to draw these units. All right, I'm kind of running out of room on this whiteboard. I really need my new one to come in. So we have large paper cups, and then we have 12 times as many small paper cups. All right, so we know that there are 96 large paper cups that are ordered. So in this large paper cup order, there are 96. They ordered 96, okay? They ordered 12 times as many, and then they want us to find out how many more small paper cups were ordered than large. So now I'm realizing that this is a multi-step problem here, okay? So before I can even answer their final question, how many more small paper cups were ordered than large? Well, I want you to think, do we even know how many small paper cups were ordered? No, we don't, right? But we do know how to figure that out because of the information they gave us. So I'm going to say, okay, if they ordered 96 large cups and they ordered 12 times that amount, in order to figure out how many small cups they ordered, I'm going to multiply 96 times 12. Okay, 96 times 12. I'll show you the standard algorithm first, and then at the end, I will go back and show you the area model if you chose to solve it that way, okay? So the first strategy you could have used is our standard algorithm. All right, so we're just going to start in the ones place. 2 times 6 is 12. All right, 2 times 9 is 18, plus 1 is 19. All right, I'm going to cross that out because I'm done with it. Now I'm going to start in the tens place. And remember, when I start multiplying in the tens place, I have to start recording in that tens place. So I'm going to put a 0 in the ones place. All right. So I'm going to think about 1 times 6, which gives me 6. And 1 times 9, which gives me 9. So now I'm going to add my two partial products. 2 plus 0 is 2. You see that? 9 plus 6 is 15. 9 plus 1 is 10, plus 1 is 11. So 1, 2, 3, comma. I now know that they ordered 1,152 small cups. Okay? And because Miss Cacibauda has not changed, even though she's on the video, hopefully you caught this, that I forgot to do something up here. All right? I got so caught up in these small units, drawing all these units, that I totally forgot. So, 1, I forgot to label that. I don't know how many small cups there are, right? But I also forgot to label the final question that they're really asking me, which is how many small paper cups, how many more small paper cups were ordered than large? So now I know that there were 1,152 small paper cups ordered. Okay, so I'm going to label that here, 1,152. Okay? Now, the unknown here, though, is how many more small paper cups were ordered. So I'm trying to find the difference. This amount here, what was the difference between how many large cups they ordered and how many small cups they ordered, right? This is my unknown. This is what I'm trying to find out, all right? So if I know that it says how many more or how many fewer, I always know that that means I'm going to be finding the difference, right? So if I'm finding the difference, I know that I'm going to be subtracting. All right, so I'm going to take my small cups, 1,152, and I'm going to label this as the difference so that I know what it is that I'm trying to figure out here. All right? So I'm going to say 1,152 minus the large cups, which was 96. And I'm going to subtract. Okay. Can I take 6 from 2? No. So I'm going to go over to the tens place, borrow from the 5 tens, and that will become 4 tens. And I'm going to regroup over into the ones place, and the 2 will become a 12. All right. 12 minus 6 is 6. All right. Then, can I take 9 from 4? No. So again, I'm going to go to the hundreds place now, and I'm going to borrow from this 1, and this will become a 0. I'm going to regroup, and this is going to become a 14. All right. All right, now, 14 minus 9, that's going to give us 5. 0 minus 0 is going to give us 0, and 1 minus 0 is going to give us 1. So I can see now that they ordered 1,056 more small paper cups than large. Okay, so again, I would be writing that in a statement. I don't have as much room, so make sure you do that on your paper, but I am not going to do it on my board. All right, so again, restating that question, how many more small paper cups were ordered than large? All right, there were 1,056 more small paper cups ordered than large. Okay, so moving down to your daily closing, kind of like your exit ticket, write a 1 to 2 minute commercial to use at home when asked the following question. Describe your math lesson today. Okay, so that is something fun and creative that you can do, and then present your commercial to your family. I will post this on my Instagram in case you are not watching the video or you don't watch all the way to the end. If you do come up with this daily closing and you video it, the commercial about what you learned today in math, and you send it to me, have your parents text it to me or send it to me on Instagram, I will give you extra credit. Okay. So yeah, have fun with that. Make sure you get outside. Sorry this one went a little longer today. Word problems are, a long task. And let me know if you have any questions. All right. See you guys tomorrow. Bye.